Hello, welcome to another lesson, and today we're going to start Unit 5, which is based on systems of linear equations. So when you have, for example, two lines, how do you figure out information about where they cross, or if they're related in some way, or solving generally for x's and y's, and then determinants. But today we need to set up what a linear equation is, graph them, get some general understanding of what they are, and then we'll move forward from there. So let's get started. First thing first, we're going to graph linear equations by finding the coordinates of 3 points. In fact, what I plan to cover in this video are these topics. So we're going to graph linear equations. We're going to do that by a table of values method, so using 3 points, and then we're going to find the intercepts. Intercepts being where the line crosses the x and the y axis. Then we're going to get into slope. We're going to find the slope of a line given either 2 points, we're given the equation in slope-intercept form, which you might recognize as mx plus b form. That's the slope and the y-intercept given. And then finally we're going to be finding the slope given the graph itself, so given what the graph looks like. But before that, let's start at the very first step, which is graphing them using 3 points. So it says the graph of an equation whose standard form is ax plus by equals c, where a, b, and c are constants. You come in front of your x's and y's. That's a straight line. They're called linear equations. And it says if a is 0, so one of the coefficients is 0, we have by equals c, b equals 0, we have ax equals 0. Basically, it's just trying to help you understand what it looks like to have a straight line. So you have a straight line. If you have linear equations, essentially you have the coefficients on the x and y are 1, or you have no squares, cubes, or just generally powers. Powers outside of the number 1, for example. So here, if we look at this first question, the graph of the following equation are straight lines, because we have a coefficient with an x, we have a coefficient with a y, and we have a 6. So all we have is a single x and a single y, so we know that that's a straight line. In this case, y equals -2. In that case, it is a straight line. It means that the graph in this case would have all of its y values equal to -2. So it would cross through this -2 point here. That's supposed to be a different color. -2. It means that every value would be at -2, it's a horizontal line where it goes through the point -2 at all points. X equals 5, same idea. Think of your y and your x values. Well, if your x value is always 5, so at the point 5, that means we have a vertical line, because no matter where we look on this line, the x value is always going to be 5. So it is a line, it's just vertical. X equals 5. That means that the coefficient, in this case, in front of the x would be 0. What I mean by that is, remember we have ax plus by form equals c, some constant. Well, if a was 0, then it would cancel this term, and you would get something that looks like, 5y equals 5, which if you solve that means y equals 1. So technically, y equals 1 must be a straight line because it came from our case here. So if a was 0, b was 5, c was 5, then it would eventually give us a straight line like this. But don't worry too much about that. If you have y equals a constant, it's going to be a horizontal line. If you have x equals a constant, it's going to be a vertical line. And if you have a mix, it's going to be an angled line. It'll go up at an angle. So let's start graphing the equations so we can make some sense of this. Graphing linear equations, we need to follow these steps. Construct a table of values of 3 ordered pairs. Then we're going to plot them on the graph that we've been given. And then we're going to join the plotted points by a straight line, and then we'll label the graph as appropriate. So let's get started here. The first thing it says is we need to graph the equation 2x minus 3y equals 6 using 3 points. So step 1, make a table of values. X and y. And we want 3 points, so I'm going to make 1 row, 2 rows, and leave a third row. Now we want to be clever about how we choose to fill this in. So let's just say two easy cases. Let's say if x is 0, what does that give? And if y is 0, what does that give? And we'll use our equation to figure that out, okay? So using our equation, sorry about that, let's try this. We know that 2x minus 3y equals 6, correct? So let's try the first case. 2 times 0 minus 3y equals 6. When x is 0 for this graph, what is y? Well, 2 times 0 cancels out. If we solve that, negative 3y equals 6, that means y must equal to negative 2. So I'm going to put that into my table here. Negative 2. And I could plot that right now, or I can plot it later. I'm going to plot it later. I'm going to do the same thing with the second case. All right, so this set is number 1. I'm going to do a second step. When y is 0, what's x? So using my equation again, that obviously cancels out. That leaves me with 2x equal to 6, and if we divide both sides by 2, x must equal 3. So color that again. It gives us 3. Now we have two ordered pairs. What this means, for example, is that we have a point where x is 0 and y is negative 2. I can go ahead and plot that right now. When x is 0 and y is negative 2, I have this point here on my graph. So I've just put that point on my graph here. Finally, or next step, we have a point 3 and 0. So when x is 3, y is 0. So that's the point right here. That would be enough for me to make my line. So I could actually draw my line here. I'm going to draw it in pencil so that if anything changes, I can change it later. Maybe I'll redraw it over it after. But that should be my line. I should do a third check just to make sure that I'm correct. So my third point, what's my third point going to be? How am I going to figure that one out? Well, I'm going to look at the 2 points that I've made, and I'm going to make a bit of a guess here. It looks like it goes through negative 3. So at that point, x looks like it's negative 3. So let's just put down 2 times negative 3 for x, and see if it gives back negative 4 for y. And if it does, I know that that's my third point. So it's negative 6 minus 3y equals 6. If you rearrange that, you'll get negative 3y equals 12. And if you solve for y by dividing both sides by negative 3, you get a negative 4. So it looks like my point negative 3 and negative 4 is indeed my third point, which means I can just confirm that this is my line. All right. So normally, if you want to do this, the fastest way is probably to check where x and y are 0 by getting the intercepts, and then you'll plot them. And if you have to do a little bit of problem solving to get the third point, that's okay. Let's try one more case. Before I move on, I should write down that my ordered pair here is negative 3 and negative 4, just for clarity. And by the way, this is in the form x, y, ordered pairs. Okay. Let's move on to a slightly different question. So you can see this can be done a number of ways. And sorry about things that keep jumping up on the screen. I'm trying to fix that. So in this question it says, graph the equation y equals x using 3 points. Y equals x. That's a bit of a weird situation, but let's just double check that it should be a straight line. Y equals x. In our regular form, we want ax plus by equals c, where a, b, and c are constants, and x and y's are variables. Let's see, if we rearrange this, move it to the other side, it means that we have negative x plus y equals 0, which is in the right form, right? A here would be negative 1, b here would be 1, the coefficient in front of y, and c would be 0. So this is a straight line. So we're okay. It is a straight line. Let's do our table of values. You don't need any of this stuff in your final working, so I'm actually going to delete it. You can rewatch that if you want help. First thing we need to do is set up a table of values. And what you'll probably notice is that we have a bit of a different case here. We could probably put 0 in and see what happens, but if we put 0 in for one of these, we get y equals 0 for the other. Okay, that doesn't really help us a whole lot. I mean, I can put in 0 and get back 0. So we know that that's true. Once again, if y equals x and y is 0, then x must be 0. Or in other words, if x was 0, then they would both give each other. Okay, fair enough. But that only gets us so far. We need to try and guess at the others. So if you're not sure what to do next, you should probably just use, you know the line is going to be somewhere in this region. Just use the numbers 1, 2, 3. So let's say, well, if it was 1, what if it was 2? Just try easy numbers for those. So if x is 1, and y equals x, and y equals x, if x is 1, then y must be 1. So we put in 1. By the same token, if we set x equals 2, then y must equal 2. So the value will be 2. So the idea here is we're putting in our x value and we're getting back a y value. You could do the same thing. But in the end of the day, y equals x, so whatever number we check is going to equal to that. So y equals 1, x equals 1, y equals 2, x equals 2. So it looks like we're just going to get this straight line like this. So that would be great. Okay, that's close enough here, 45 degrees. And so y equals x always looks like this. So it always looks like this, and it crosses the point 0, 0. Okay, so something to keep in mind. Negative y equals negative x would be a complete opposite, but we might see that later. Let's try one more example. Graph the equation y equals negative 2x minus 1, and we're going to use do it using a table of values. So 1, 2, 3 points is going to be enough. In fact, 2 points is enough. 3 points is just to make sure we can check it. In the absence of any other kind of clever information here, we're just going to put in 0 for x, and then I'm going to use 1 and 2. So we'll say 0, 1, and 2. When x is 0, what do I get? Well, y equals 2 times 0 minus 1. What does that give me? It gives y equals negative 1. So y is negative 1 for that. 0 and negative 1 looks like this. If x is 1, so negative 2 times 1 minus 1. What's that going to give me? Negative 2 times 1, that gives negative 2 minus 1 is negative 3. And finally, y equals negative 2, but my x is 2 minus 1. It's negative 4 minus 1, or negative 5. So negative 5, that means I have the points 0 and negative 1. I have 1 and negative 3, which I'll put in now. I have the point 2 and negative 5. Okay, so just in case you're wondering where this came from, I put this x in here, and I got back this y here. And I did the same thing with the others. I put in x equals 1, and I put in x equals 2 to see where I'm going. And by the way, I'm putting this x into the original formula, and this then will give back what y is. That's the process here. Usually it's easier to put in x values because y is solved for. Okay, so y is on its own. All you need to do is put in your x and substitute and see what happens. So I'm going to connect this line now. And it should look something like that. That's not perfect, but it's good enough. And what you should do, because this line goes on forever, is I should have actually been putting arrows on all of these. So you put an arrow on that to say it goes on forever. And again, it's a little bit of a bad sketch. I have a feeling that I might have gone off a little bit in this area, but it's good enough for now. You should be very careful with that with your own workings. And yeah, this one up here should have had arrows, so make sure you put those in. And then up here, same idea. They go on forever. This is just a section of that line, but they do go on forever. They're like rays. And that's how you handle these. You start with 3 points and fill them in to the table of values and then graph. So I want to fix this graph actually, because it's not really what it should be. So I don't mean to mess up your workings, but I want to make a note here. The patterns are important. What we'll see soon is that if it goes, left 2 up, left 1 up 2 here, or if this pattern is showing, we have down 2 over 1, down 2 over 1. that pattern should continue always, because that's how lines work. So this is really the line that I should have made. So I'm going to make sure that you have the same line, because it's very important that we don't mess this up. So the line is more accurately this one. And you should always be able to check with that. It's called slope, and it's rise over run. I'm going to put in these kind of little dots here that weren't asked for, just to show you that I really should be continuing the pattern, and it'll be a lot better to make sure that you follow the same pattern all the time. All right, so now we've done our 3-point process. Now we're going to move on to finding the x and the y-intercepts of a straight line graph, which we sort of did the first time for the first question, but we're going to do it explicitly. So first things first, this is our definitions. Definitions, DEF with an N up there. The x-intercept is the point where a straight line crosses the x-axis. It's where the line intercepts the x-axis. Its coordinates are x0, since any point on the x-axis has a coordinate of 0. So the x-intercept in this case is down here. Notice how it crosses the x. By the same token, the y-intercept is the point where a straight line crosses the y-axis. Its coordinates are 0y, since any point on the y-axis has an x-coordinate of 0. So notice the y-intercept, its x-coordinate is 0. Our x-coordinate, or x-intercept, had a y-coordinate of 0. Remember, think about this. It crosses the x-axis, which means it has a y value of 0. If it crosses the y-axis, which in this case we're doing here, it crosses the y-axis, that's where x is 0. I should have said that for the first case. If it crosses the x-axis, y is 0, because it's hitting this point, y equals 0. If it's crossing the x-axis, look and see that your x value there is indeed 0. So something that you should try and get into your head, but we'll try to make it clear with more examples, okay? So let's move on to the example part. To find the x-intercept from an equation, let y equal 0 and solve for x. Let y equal 0 and solve for x. What that looks like is solve for x by setting y equals 0. So really we're going to look like this. We're going to have a blank and figure out what that's going to be. For the y-intercept, let x equal 0 and solve for y. What does that look like? You're looking for the y-intercept, so you don't know what the y value is. I'm going to leave a blank there. Okay. So let's jump right into an example so you can see how I'm going to do this. Example, find the coordinates of the x and y-intercepts for this equation. So we're looking for the x-intercept and we're looking for the y-intercept. And we've been given the equation. So first of all, let's find the x-intercept. The x-intercept is found by setting y equal to 0. So that y equals 0. Now we're going to write out our formula, 2 over 3. I'm going to write this one out, but just let y equal 0. Everything else stays the same. You'll notice I just have x, the x-intercept is my unknown. Anything multiplied by 0 is 0. So I end up with negative 1/2 x equals 1. I'm going to multiply both sides by 2 now. That'll cancel out the 2 on bottom. I'll end up with negative x equals 2. And divide both sides by 1. That means x must be negative 2. So the x-intercept is negative 2. And 0, of course. You need the actual coordinate. If x is negative 2, then the x-intercept is negative 2 and 0. Let's do the same thing for the y-intercept. The y-intercept has x equals 0, but we don't know what the y value is. That's the whole point. Remember, the y-intercept, we know that x is 0 here, but we don't know the y. So let's solve for it. Again, we let x equal 0 to find the y-intercept, and then use our formula. So 2 over 3y minus 1/2. X is 0 here, so it'll equal 0 and 1. For the y-intercept, remember, We're looking for the y value. What do we have here? Well, anything times 0 is 0, so that cancels out easily. That's a really nice consequence of using this method. 2 over y equals 1. How are we going to get to this? We're going to multiply by 3 over 2. On both sides. That'll cancel the 3's, it'll cancel the 2's, and gives us y equals 3 over 2. If y equals 3 over 2, that means that the y-intercept must be what? Well, let's think about this. At the y-intercept, the x is always 0. The y value is what I solve for. So it's 0 and 3 over 2. Okay, so we have our y-intercepts. Why the heck did we even get this? Why are we looking for the y-intercepts in the first place? Or the x-intercepts? Well, if we have 2 points, we can now draw a line. And so that's what we're going to do next. More formally, but if I wanted to make a little sketch, if we had the point -2 and 0, it would be over here. If we had the point 0 and 3 over 2, it would be about this. And that would be the sketch of this particular line. This one being our x-intercept, this one being our y. In this question, it didn't ask for it, but really it should have asked for it. Let's do a more formal example where it uses the sketch. Use the intercepts to graph an equation. So for example, graph 3x minus 2y equals 6 using its intercepts. So this means the x-intercept and the y-intercept. So let's go ahead and solve for both of those. X-intercept, which means y equals 0. We're going to say 3x minus 2y, y being 0, equals 6, and solve that. Well, that cancels out, leaves 3x equals 6. Divide both sides by 3, you get x equals 2. That means that we have our x-intercept is 2 and 0. I probably don't need to write out the rest. Y-intercept. Remember, if you're looking for the y-intercept is where we cross the y-axis, which means x must be 0. Put out our formula again. 3x minus 2y. So 3 times 0 minus 2y equals 6. If you're a little lost on where I'm getting these equations, remember, the equation is what I'm substituting into every time. 3 times 0, that cancels out. So negative 2y equals 6. You should divide both sides by negative 2. To get negative 3. And then set this up. Take a moment to figure out how are we going to write this y-intercept. What do we know? Well, we know that x was 0, so we have to write x equals 0, and then our y value was negative 3. So the power of this method is that it's very simple because we're dealing with zeros, and whenever we deal with zeros, things are going to cancel, and then it makes it really easy for us to plot. So watch this. The x-intercept, 2, 0. X equals 2 and y equals 0. That's our x-intercept right here. What about our y-intercept? 0, negative 3. So x is 0, y is negative 3. It's down here. So that's our y-intercept. And then you connect them. Be very careful. Use a ruler. Be as careful or more careful than me, and try to get this sketched as best as you can. It should look something like this. That's the end of the question. I graphed the equation using its intercepts. I'm just going to do a quick check. Right here, I can see there is a distance of 2 to the right. Let me just make it a regular pencil color. 2 to the right and up 3. So my next point should be 2 to the right from the next point and up 3. And it looks like it does cross. So that's just a little bit of a check. So you can check that your line is okay. And if you've drawn the line okay, you should get another point crossed somewhere nice. We'll do one more example. I'd like you to try this one on your own. It looks like something we've never done before, but all it's asking for is for the x-intercept and the y-intercept. Pause the video, see if you can get this. Okay, hopefully you've given it a shot. Remember what the x-intercept and y-intercept means. If you mix them up, you're going to have a really bad time. The x-intercept is where it crosses the x-axis. That's here. And what's our value for that? Well, the x-intercept value is going to be whatever that is. So that's 2 and 0. On the other hand, what's the y-intercept? The y-intercept is where it crosses the y-axis. This is your y-axis, and your line is going right through that. So this is our y-intercept. And just read off the coordinates. What are the coordinates? Y-intercept here. Well, the x value is 0, and the y value is -5. So these are our two answers. You don't need to use colors, of course. I'm just using colors to help you understand. But this is the big idea here. And it matches what we said before. X-intercept has y equals 0. Right? Maybe I should make it blue. I don't want to confuse you. And y-intercept has x equals 0. Which is why we see these things match up. So just be careful. X and y-intercept is a simple idea, but it can trip students up because it can be confusing if you mix them up. All right? And that's it for this topic. We're going to move on to slope now. Objective 5.1.3 is find the slope of a straight line graph. And you should recognize this from high school, or from previous math courses at least. The slope of a straight line is a measure of the steepness of the line. The steepness is measured by determining how much the line rises vertically for every unit it runs horizontally. If we let m represent the slope, we have m equals rise over run. So it means how much you go up by how much you go over. Or in other words, it's how much you go over and how much you go up. But really, you should do rise and then run. Or you could be going down and over. So let me give you a little bit of a visual here as to how we're going to calculate this. So in this particular situation, it looks like we have a ramp, and the ramp is 3 units high and 4 units long. Well, we're saying that the slope is the rise over the run. So what we have are 2 points that we know, this one and this one. What's the difference in the height from 2 points? Well, it goes up by 3, and it goes over by 4. From the left point to the right point, it goes up by 3 and over by 4. So the slope is 3 over 4. If I move things around, or I make this longer, for example, my length is now 7, my run is 7, rise is 3, it should be 3 over 7 is my slope. Sometimes they simplify, so in this case it's 3 over 6 is my slope. That would be a 1 over 2, because 3 over 6 simplifies to 1 over 2. The same idea works if you go down. So in this case it's a little hard to see that number, but if we go over 6 and down 3, let me make it more clear. This rise, from start to finish, the rise is actually -3, and the run is 7. So it's -3 over 7. That's why that negative comes out. And let me see what else we could do here. Maybe just make it really big. Yeah, okay. Our rise here, from start to finish, our rise is -5, our run is 10. -5 over 10 simplifies to -1 over 2. Same thing here. If we had up 4 over 9, 4 over 9. So let's see how that relates to our notes. Our notes say that this is our slope formula, which it absolutely is. Change in y values, y2, y1, those are just 2 y values of 2 points we know. This is our rise, that's the difference in y values, and the bottom ones are our run. All right. So our positive slope, if we were to break this up, a line that has a positive slope here, this would be our rise from start to finish, this would be our run. Or you can even break it up on the other side. Like the little diagram I showed you, the little interactive thing, this would now be our run on bottom, and this would be our rise. It doesn't matter which one you use as long as you use the right one in the right order. And negative slope, same idea. Negative slope goes down. So maybe something to keep in mind. Read the lines from left to right. So your first point will be on the left, and then if you read it from left to right, it'll be the second one there. So for example, this would be our point 1 and this would be our point 2. And if you do it that way, point 1 on the left, point 2 on the right, you're not going to have any trouble. Let's do some examples so that I'm not just talking gibberish to you. Example 1. Find the slope of the line. Slope of the line is rise over run. In other words, it's y2 minus y1 over x2 minus x1 through the points 2, -3, and 5, 3. Well, this point here, this is going to be point 1, this is going to be point 2. The order doesn't matter when we don't have a picture, really. So what this means is that we've been given x1 and y1, we've been given x2 and y2. Those relate directly to our formula. So we can say slope, also known as m, equals y2 minus y1. So y2 is 3. y1 is -3. So 3 minus -3 over, what's x2? Let's go find it. Where is it? Where is it? Where is it? x2 is 5 minus x1. x1 is 2. So in this case, 3 minus -3 is 6. 5 minus 2 is 3. 6 over 3 is 2. And there we go. We got it. This line, the slope is 2, which means it's not too steep. Slope of 1 is very low. Slope of like a decimal is very low. The bigger this value, the steeper it is. Okay? There is an alternate method. I mean, maybe you tackled this a little differently. Maybe you got your points backwards, for example. Well, in this case, it doesn't matter. You can say slope is, what if you started with the -3 first? So -3 minus 3. And what if you started with the 2 first for the x values? 2 minus 5. Maybe you were worried that that's going to mess things up. Turns out it doesn't. It gives -6 divided by, what's 2 minus 5? -3. It gives that. So no matter what method you use, you're going to get the right answer. Just be consistent. Make sure that the y1 and x1 are together, the x2 and the y2 are together, and you should be okay. For example 2, we want to find the slope of the line through the points -1 and 2, and 3 and -1. So I'm going to put the answer here so you can check the work. Your answer should be -3 over 4. So I'd pause the video, see if you can get the answer of -3 over 4. All right. Hopefully you were able to get it. If you weren't able to get it, again, no pressure. Let's get it together. So you're very clear on what's going on here. I'm going to call this is our point 1, this is our point 2. I've just chosen 1 and 2 because of the order that I see them. That means that -1 is x1. This is x1 here. This is y1. This is x2. This is y2. Again, I'm not trying to make it confusing. We're just, x1 is -1 here. And we're going to use our formula now. So our formula for slope is also known as m. So it's very common to use m. It's rise over run, y values subtracted over x values subtracted. So I'm just writing out the whole formula. You don't need to write every piece. I'm just showing this so that we're clear on it. All right, what are we going to do? y2 minus y1. y2 is -1 minus y1. y1 is 2 for us. I'm using brackets just to keep everything separated. x2 minus x1. 3 minus x1 being -1. So what's -1 minus 2? Some students say it's 1, or they get all sorts of crazy stuff. It's -3. Make sure you can get that. 3 minus -1. That's a 4. And there's nothing to simplify, so this is my answer. Slope is -3 over 4. So that's how we do slope. If you want to sort of visually confirm your answer, you could check by making a little sketch. We know that our point in the beginning was -1 and 2. -1 and 2 is up here. 3 and -1. 1, 2, 3 over, down 1 over here. That's got a negative slope. So at least the negative is okay, and it looks okay. For the previous question, we could have done a similar thing. We get a positive slope for this one. You just check it. Make a little cross with your axes, and let's say we've got 2 and 5. So the value 2 and negative 3, 1, 2, 1, 2, 3. I've got a point there, and I've got 5 and 3. 1, 2, 3, 4, 5 over, up 3. So you don't need to do this. I just want to check that the positive slope makes sense, and that does make sense here. A slope of 2. So you're going up 2 for every 1 you're going over. Okay. Again, that little check is optional. You don't need to feel like you have to do that. What else do we got? When an equation is given in the form y equals mx plus b, that's a key piece of information. We can easily determine the slope and the y-intercept. Okay, what it means is, find the slope and the y-intercept of y equals 3 over 2x minus 3. Well, it means exactly what it says. 3 over 2 here, that's our m. m must be 3 over 2. And it says plus b. How did I know that m, by the way? Well, it's the first thing in front of the x. What about b? Well, plus b, in our case, matches negative 3. That means that b must be negative 3. So to write it out formally, you could say the slope is 3 over 2. You can say the y-intercept is negative 3. Because y, once again, m is the slope, and b is the y-intercept. So if it's in that form, y equals mx plus b, we're very well off. And I'll do one last thing, just to make it crystal clear here. The form that we're matching is this. So m must be 3 over 2. And b, positive b, or b, is negative 3. So if you're given it in slope-intercept form, which it doesn't say what that's called, so I should probably tell you, it's slope-intercept form, you're being given a gift. If it's already in slope-intercept form, you kind of have very little to worry about. It's going to be a pretty easy problem. All right. Let's move on. We're almost done here. Determining the slope of a line from a graph. I love these because it's very visual, okay? And it says what the steps are. These are the steps for determining the slope from the line of a graph. Sorry, determine the slope of a line from a graph. Choose 2 points on the line whose coordinates are easy to read. What does that mean? Well, it means look in the space here and try to find a very easy point for yourself. And then we're going to use the formula to calculate the slope. So let's look at this, and you tell me, you look at this and tell me where it crosses nicely, on one of these points here. Something that we can read very easily. And when I look at this, I see a lot. I see the point negative 4 and 6. I see the point 0 and 4. I see the point 4 and 2. I see the point 8 and 0. Those are really obvious, and then you could even go in between if you wanted to and use these. You could read those off okay, but they're a little less easy. So I'm going to keep away from those. All right, so it's a nice idea to write those, what these are. This is 0, 4. This is 4 and 2. And this is 0. Oops. This is 8 and 0. Okay, so why did we do that? Well, if we do that, we can easily get the slope. Okay? The reason that it doesn't matter what points we choose is because the slope is the same for any 2 points on a given straight line. So let me write that down. What I've said is the slope is the same at any point along this line. Any point. You can choose any 2 points to get the correct slope. All right, that's the most important piece here. Choose the 2 points that are easiest for you. So no matter what, let's just say I look at this and I say, okay, I think this is easy. And just by looking at the graph, you could say this is going down 2, and this is going right 4. also known as rise is -2, and run is +4. Or you could see the same thing here. You're going down 2 and right 4. Okay, how does that help us? Well, then we could say the slope is the rise over the run. And no matter what way we slice this, we're going to get a -2 over a 4. You might wonder about this negative. The negative means we're going down. I mentioned that earlier, so you might want to rewind and check that just in case you lost what I was talking about. That's -1 over 2 is our slope, which is, it's nice to write these in fractions, or if you want to, you can write -0.5. They mean the same thing. So that's one way to do it. Another way to do it is be more formal about our process. Use the formula. So I'll say or. You could say the slope is y2 minus y1 over x2 minus x1. And just for the sake of argument, let's say our y value is y2 and y1. Let's just say that this is 0.1 and this is 0.2. Again, it doesn't matter. I'm just choosing whatever. Or I'm going to choose this point as 1 and 2. If that's our points, then y2 is 0, y1 would be 4, x2 is 8, and x1 is 0. And I chose that because I saw all these zeros, okay? And then that gives me -4 over 8, which simplifies to -1 over 2, which is exactly the same thing as what I had before. Even the decimal works out to be the same. So I guess these would be two different methods that get you to the same thing. This would be more of a visual method, and the other way would be like the formula method. All right, visual method means we look at it, we're like, okay, go down 2 over 4, -2 over 4, that's my slope. Or you actually take 0.1, 0.2, extract your y and x values from that, and then use your formula to move forward. So that is all I'm going to cover today. The next topic is related to slope, but I think it's probably enough for one video. I just want to jump right back to the top just to summarize. What we did today was we did table of values. We chose 3 points and graphed our line. We did x and y intercepts, so you need to know how to find an x or a y intercept. Remember, if you want the x-intercept, you set y equals 0. And if you want the y-intercept, you set x equals 0. The slope, remember that slope is rise over run. Or in other words, the difference in the y values, y2 minus y1, over the difference in the x values, in the same order. You can't mix the order or you're going to mess it up. Then we did equation in slope-intercept form. Remember that y equals mx plus b, m being the slope, b being the y-intercept. And finally, graphing and getting the slope from a graph, which can be either the visual method or the formula method. And that's it. So I hope you found this okay. If you have any issues, of course, always let me know. I'm happy to go back over any of this. And otherwise, I'll see you in the next class. Have a great day.